In this lesson, we'll look at inserting new documents into Couchbase, as well as how to go about creating unique document keys, because a defining feature of a Couchbase bucket is that each document ID, each key, is unique. So first, you need to get the document. So how do you access posted JSON using Slim? Well, that's quite straightforward. You can parse the body of the document as JSON using the getParsedBody method. You'd find that Slim implements the PSR7 server request interface, providing a whole host of methods for accessing the body of a request. It's all just a Google away, we won't dwell on it here. But it does mean that once you've parsed the JSON body, you could easily access any value within the JSON for use as a document ID or otherwise, as we see here. Inserting a new document to Couchbase is straightforward. One of the beauties of Couchbase is ease of use. All you're doing is inserting a key value pair. Now your key is a string, or as we'll see later, potentially an array of strings. The value is any binary value up to appropriate length, in this case specifically a string of JSON. You can pass options along with the insertion. You could pass an expiry, which is a number of seconds after which the document will auto-expire. Remember that Couchbase has its roots in caching, so you could implement this for session management quite easily. You also have persist to and replicate to options to verify the persistence to n number of nodes, which would include the master, or replication to n number of nodes, which would not include the master, as appropriate for your particular application, if these factors are relevant. What you get back is a document, as we've seen. In this case, the document has its CAS or check and set value populated. This is a unique identifier for this particular version of the document that can be used for optimistic locking and similar behaviors. The value in this case would not be populated. Well, if you've spent any time with traditional databases, and I'm sure you have, you're used to the idea of an auto-increment field within a table to ensure a unique ID for each record that's added. Similarly, you can use counters to ensure a unique value throughout a bucket. You can also create as many of these counters as you like for the bucket. So, to create or to get the most current value of a counter, you use the counter method. The first parameter is the name of the counter. The second is the delta, the increment for this particular use of the counter. The options in this case are two. You can specify the initial value if it is newly created on this particular invocation of the counter method, and you could also set an expiry if you want your counters themselves to be auto-expiring. What you get back is a document, and the value in this case is going to be the incremented most current value of the counter. You could then use that value to ensure a unique document key, because if you're using the first name of somebody out of a document as your document key, that's probably not very unique. So you might want to take a slightly more involved approach to key creation as we see here. Of course, your mileage may vary. The point to end with here is that these counters are just one more document in your bucket. You can go in and take a look at them. This is why they're available cluster-wide, just like the rest of your data. So how could you externalize some of this behavior? You would create a new folder in your code, a namespace such as app/utils, and then within it you could create, for example, a utilities class to expose helper methods. You would then modify your composer.json file to specify this new path and namespace to be autoloaded when the application starts up. But then the class map of classes to be autoloaded needs to be updated, so you can use Composer to dump and rebuild this file. How you use Composer, as we've already seen, depends on whether you have it installed locally as a composer.far file, in which case you invoke it through PHP, or globally. Once you've done this, you can then use your utilities class in your code, even potentially add it to your dependencies file so that it's injected into every route for easy use. Again, there's more on all of these approaches and more about externalizing your route handling code into handlers in the Slim framework documentation. So what have we learned here? First, we saw that Slim request objects implement the PSR7 server request interface. This exposes a series of methods, including getParsedBody to grab the JSON and make it easily available to you from the request. We saw how the insert method accepts one or potentially more IDs, as we'll see ahead, and then the value or values. The values presumably are going to be a string of JSON, but not necessarily. Couchbase can store any binary value of appropriate length. And then you can configure options enabling auto-expiration of your documents, as well as verification of the persistence and/or replication of those documents, as appropriate for your application. We saw how you can use the counter method in order to ensure unique IDs. This is similar to auto-increment fields in a traditional database. The counter method accepts the ID for this particular counter within the bucket. You could have as many as you like, as well as the delta and options. The options enable expiration of the counters, as well as let you configure the initial value of the counter, because if it doesn't already exist, it is created on the first use of this method. Last, we saw how Slim supports custom class auto-loading and injection in case you want to start externalizing some of your code, as you likely will. In the lab for this lesson, you'll create new documents and insert them to Couchbase through the post route. You're also going to implement a counter to create unique IDs, and then optionally externalize that code into a utilities class. When you're done with that, come on back. We've got a lot more to come.